In this lecture, we're going to learn about unordered sets and maps. And these are other versions of std set and map that are not going to order their data in any way that is useful as users of these containers. And this is done to improve performance of these containers. Internally, they are going to use what is called hash maps to order their elements. And that's going to make operations on them even faster than std set and std map. But don't take this for granted because this is really going to depend on the specifics of the data that you are storing in your containers. It is possible to provide your own hash functions to control how elements are ordered in these unordered sets and maps, but that's well beyond the scope of this course, so we're not going to discuss this any further. But note that to decide whether you use unordered versions of set and map or ordered versions, you really need to run real performance tests on your real data and make your decisions on top of that, because these things can really spin out of control if you don't tune to your data that you are working with in your C++ program. But in most cases, it won't really matter, so the difference is not going to be that significant. And in practice, I choose to use std set and std map because they give me ordering that I can control directly either through comparison operators or callback functions that I can pass to my containers. But that's my preference. You will have to make your own choice. Other than these differences, you can really use these containers like we have seen before. So I won't be giving you many examples, but I am going to tell you a few things. So to use them, you will have to include an ordered set and an ordered map. And once you do that, you can create your containers just like we have seen before. So for example, you can create your std unordered set like this and pass in a template parameter. You can create a map version of this, and this is going to work really well. You see that all we need to change is the name for the collection, and everything is going to fall in place, and this is really cool. This is one of the benefits of using the STL. Now, if you want more information, I would advise you to come back to our documentation here and learn about all these unordered associative containers. You see that we have an ordered set, an ordered map, we have an ordered multiset, we have an ordered multimap. You can use these if that makes sense for your application. But in most cases, ordered versions are going to work really well, and you have more easy control on how your elements are ordered so that you can see that in your C++ program. But this is my preference. You will have to decide what works better for your use cases. For now, I am going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is an ordered set and an ordered map. I am going to grab the code from our template files, and I am going to paste in the code. Let's open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file that we can open up. Let's remove what we don't need here and close the left sidebar. And we're going to include multiset. So let's do that. We're going to say unordered set and unordered map. I think these are what we need. Let's do map. This is what we want here. We can also put in set and map. Let's do that. So let's say set and include map. We are going to put in our functions to print our data. We have one to print set information and one to show map information. And we separate them because for map, we have two pieces of information. We have key and value information, and we get the information using our loop here. This is going to work really well. Now we can hop over in the main function and put in the code we saw exactly in the slides. We're going to set up a bunch of set and map collections, and we're going to print them out. And this is going to order elements. This is not going to support duplicates because this is std set and std map. So if we put in duplicate information for set, that's not going to work. If we put in duplicate key information for std map, that's not going to work. But now you see that our data is going to be ordered for set and map here because that's how these things are designed to work. Let's pass this through our compiler. We're going to use GCC. The build is going to be good, so let's clear let's not do that yet. We're going to bring up a terminal window and we're going to clear now and run Rooster. We're going to see that our data is going to be ordered 2, 6, 11, 15, 16, 9, 12, and 0, 1, 2, 3, 4. So data is ordered, but if we change and use unordered versions of these containers, you're going to see that the data is going to be ordered in a way that doesn't make any sense to us. Let's show you an example. So we change this to use an ordered set and an ordered map, and we're going to print our collections again. Let's pass this through our compiler. The build is going to be good, so let's clear and run Rooster. And we're going to see that the data is going to show up in a way that is different than the order we put in the data, but this is not going to be ordered from smallest to greatest. So this is going to be ordered in a way that is going to make easier for the computer to search for data in this collection using what we call hash maps. But I don't really want to go into these. That's really out of scope for the course here. But note that using unordered sets and unordered maps will give you a chance to make your code work even faster. And as I have said in the slides, you will have to do your own research and decide which one is better for you, whether unordered versions or ordered versions for these collections here. And if you want more information, you can check your reference manual. Mine is CPP reference. This is where I like to go to learn more about my things in C++. You can come back here and really visit these containers and learn all you can about them if you want to use them in your C++ application. For now, I am going to stop here in this lecture. And in the next one, we will start and learn about container adapters. And these are not really containers. They are going to be modifying a few sequence containers we have learned about to provide stack interface, queue interface, and priority queue interface. And we are going to learn about them in the next few lectures. So go ahead and finish up here and meet me in the next one.